Dear students, we'll get started with another topic. The next topic continued after the sections of solids. Now this topic is called development of surfaces. We'll just get started with this one. This is part of our fourth unit. However, this is a lengthy chapter. We do have a lot of things to do here, but we'll limit our discussion to our syllabus and to our class lecture. So this is in addition to the sections of solids, this is developments of surfaces. That's another topic. So let us see what this is. So as you can see in front of you, there is a square prism standing, and then I also made one model. Like you can see the model, just a square cross section. You can see this is your square cross section right here, and then this remaining thing is the prism which I made out of cardboard. All right. Let us get to the details of why we even need development of surfaces. All right. So let's lay the first line here. Assume that the solid is wrapped with a sheet of paper. What is development of surface is the first thing which we want to discuss. Basically, if it's a solid is wrapped with a sheet of paper or a sheet metal or any surface, some sort of packaging material or anything, like if it is wrapped around it, when it is developed out or opened out or spread out to make it coplanar with a surface, or it's like the surface of the solid is laid out on a plane, how does it look like is called the development of surface. It's as simple as that. All right. So if the solid is unwrapped and the sheet of material unwrapped is made coplanar, its surface is called the developed surface of the solid wrapped. Okay. Or it's also called surfaces of solids are laid out on a plane. All right. So in front of you see the square prism. All right. This is the diagram which you can see. This is the diagram. All right. And then this is your model. Like I made a model. Like now I remove the square surface here, so you can see the square cross section right there. So I'm just setting this aside. This is the square. I'm just putting this aside. Right. Now this is your square cross section. You see, and then this is wrapped with a sheet of paper. Okay, you can see it is wrapped with a sheet of paper. The same, this is in form of model, and here you can see the diagram. Like this is the square ABCD, this is the top base, and this is the bottom base A1 B1 C1 D1. Okay, this is wrapped with a sheet of paper, okay, which is fitting exactly to the each face of the prism. Okay, apparently for a prism you have a rectangular face. Okay, the base would take the shape of whatever the base is. It's a triangular prism or a square prism or a pentagonal prism, whatever the prism is, this would be taking the shape of that. Okay, in this case it's a square prism. Okay, this is wrapped with a sheet of paper or sheet metal, whatever. Okay, this is the example I've quoted here. Now this one, if it opens out, this will form out. This is like one rectangular face. This is number 1 here. Okay, I named it number 1 here, number 2, number 3, and number 4. These are the 4 rectangular faces which are unwrapped from the square prism. This is what it is. Okay, this is called the development of the square prism. Okay, so basically the lateral surface of the square prism has been developed. So lateral means the surrounding surface of the square prism. Okay, top base and bottom base can also be developed based on the requirement. Okay, some cases it is required, some cases it may not be required. So depending on the requirement, we will do the developments. Okay, you can look at this model once again. Square prism, this has been wrapped with a sheet of paper. Now I have named some names here, A, B, C, D, so on, for each of the edges, long edges. So this is A, A1, B, B1, so on. Okay. Now if this is opened out, how does it spread out? This spreads out to be one rectangle, second rectangle, third and fourth rectangle. 4 rectangles spread out. Okay, starting off from A, B, C, D, and then A again. So these both will be joining like this. Okay, with this, like we can wrap the square prism. This is what it is. Okay, so this is basically the applications. We'll talk about the applications in a minute. So this is the square prism which was wrapped with a sheet of paper, and then that develops out to be like this. Okay, similarly if it's a pentagonal prism or whatever prism it is. Like today we'll confine our discussion to the prisms and cylinders, which would basically use the parallel line development method of developments. All right. So we'll just move on to the next case, next slide. We will talk about the applications here. what are the applications of the developments of surfaces. Okay. In many industries, it's used in many industries like automobile industries, aircraft industry, shipbuilding. Okay, in packaging, sheet metal works. So the sheet metal which is made out of your cars, like let us say you have a car and then car is made of a certain metal, like whatever color the car is, base of that would be a sheet metal. Okay, some sort of a gauge use, some sort of thickness is used for the sheet metal or steel or whatever that metal is, aluminum alloy or whatever that metal is, that is used to make spread out a sheet, and that sheet is used to basically make that solid object, whatever that is. Okay, whether it's automobile, aircraft, cars, ships or whatever. Then packaging and sheet metal works, like they do some sort of packaging, and nowadays packaging is very important to keep the products safe when they are being delivered. So the packaging, whatever the material required, that material is optimized by knowing what is the dimension to be covered, and then based on which you will have your section developed out. Okay, the developed section would be used. Similarly, in case of boilers and bins and process vessels, hoppers, funnels, chimneys, these are some of the applications of the developments of surfaces. All right. Now, it is easy and convenient to develop the regular solid surfaces like polyhedra. Okay, it is definitely pretty simple, like as you have seen in the square prism example. It's easy to develop out the surface, since we know that the bases are the square bases in a square prism, and there are 4 faces. If you have a square prism, it will have 4 faces developed out, 4 rectangular faces. Okay, there is no confusion in this. Similarly, if it's a pyramid, you will have an isosceles triangle, and whatever the base is, like it's a triangular pyramid, then you will have 3 triangles spread out. 3 triangles would be, each of them would be an isosceles triangle, with having the base edges the side of the base of the pyramid, and the side of the isosceles triangle would be the slant edge or slant length of the pyramid. This is how it is. Okay, that should be a true length, by the way. Okay, these are some things you have to keep it in mind. In the next thing, we'll move on to the methods of developments. There are several methods of developments. Okay, so now the first one is a parallel line development, which is used for prisms and cylinders. Okay, this is what we are going to discuss today in our class. Second one is a radial line development. This is used for developing of pyramids and cones. This we'll do it in a later class. And then this is triangulation development and approximate method. These are some of the things which are used for developing of transition pieces. Okay, and then this is like a develop double curved or warped surfaces. Okay, some surfaces which do not have a proper or a regular shape, those things can be made by using this method. Okay, approximate method. Triangulation is like basically you will have transition pieces made into small pieces of triangles or whatever shapes it is, and then develop the surface. We'll move on to the next slide. Okay, this is your first problem. We'll get started off with this one. This is taken off from the ND Butt textbook. So you see in front of you, this is the problem. Okay, draw the development of the lateral surface of the part P. Part P in the sense, this is my part P. Okay, part P means this is whatever this cross section is there. This is what it's given in the textbook. You guys can look it out in the textbook. Okay, it's a pentagonal prism, a side of base parallel to the VP. Okay, one side of the base is parallel to the VP. So this is what the question is given, and this is the diagram given to you. Now from this diagram, what do we know? We do not know that this is like in what position it is. He says that one of the edges parallel to VP, and then somewhere he didn't say where it is though, but only thing he says is one of the side of the base is parallel to VP. This is what I know. So looking at the diagram, I can see these are the solid lines. Okay, these are the solid lines. I can name this like I'm counting the solid line 1, 2 and 3. This is 4 and 5. Those are the dotted lines. So I'm saying this is my A1, this is B1 and C1. I am counting the solid lines first. This is D1, this is behind my side, and E1, this is behind my side. Similarly, I can say A, B, C, so on. Okay, so this is like, these are all the dashes, by the way. I'm going to put in dashes here. Okay, A dash, B dash, C dash, D dash, and E dash. This is what it is. right? Now let me get the base shape here. So if I drop this down, I'm just, the base shape is not given to me, but I'm just drawing just for my understanding. So this is my base shape. He said this is the one base just parallel to VP and some distance in front of VP. This is what I've taken. I'm considering, I'm assuming that this is some distance in front of VP. So this is the base shape I've drawn. So constructed the pentagon. You guys can construct the pentagon. So this is my center, let's say. Right. So I have my front view on top of the pentagon. So I can see this is my ABC or solid line. So this is my A, B, and C. This is what I see is just solid line. A1, B1, and C1. These are the solid lines. Alright. And then this is my D and this is my E. For the top part, I am saying ABCD. The bottom I can say A1, B1, C1, D1, E1. Right. So this part is done. Now let me just draw the, now it's the development part. So this one, like if you can correlate to the sections of solids which you've done earlier, like this is basically like one section which has been cut out, right? Just so that you guys can correlate. Okay, this is the end where you have a thick line here at the end. This is the section which has been cut out in the solid, and this part has been removed. This part has been removed. This top part has been removed. So this part is the one which is remaining. This one has to be developed out. Even otherwise, you have seen that in a square prism, like when it develops out to be 4 rectangles spread out. Okay, here in this case, it's a little different here. So you see in how many edges can it be cut. Okay, here like this is A1 line is cut. So that is like solid line. So I'm naming it as number 1. Number 2 solid line, number 2. Number 3 solid line. This is the dotted line. So this is number 4. This is the dotted line number 5. So these are the 5 points where the point has been cut. So now since it is a parallel line development, I have to draw the parallel lines from each of the point where the prism has been cut. This is what I'm trying to do. Alright. So let me just develop out the surfaces. Let me just develop out the base surfaces using I'm using a pencil here. So these are the parallel lines I'm using. All I'm doing is I'm just drawing a parallel line from here. I'm just drawing it very lightly. Okay. So I'm developing the whole surface, and later I'll just like confine my development to whatever. Like this is the base edge. So I'm considering the base edge. Whatever the base side is given as how much? Okay, here it's given as 25. So I'll take 25 here. And then I'll develop out the 25 mm rectangles, like the 25 mm width, and height is as it is the height given 60. So this one is developed out to be into 5 rectangles. This is what is. I just drew using a pencil just so that like I'll just finalize later. This is like a H pencil which you guys have to use it. Okay, I'm starting off my development from here. Okay, so this is my A. I'm just using a capital letter A here. I'm starting off from here. Since I'm starting off, I'm developing from here. This is my A, B, C, D, E, and A again. Okay, A ends. So this is my A1, B1, C1, D1, E1, and A1. This is what the development of the pentagon is. This is the basic development. Now let us see where the sections are being cut. So number 1 is lying on A1 line. So straight away I can pick up a point here. This is my number 1. And then A1 is one more here. So one here and 1 there. Now let's go to second point. Second point is on the B line. So if I draw a line here, so you can use a pencil to draw the line, right? And this is where it stops. Similarly, 3 would stop on the C line somewhere, wherever this is coincide. This is the parallel line I'm drawing. And then 4th point is right here on the D line. So this is my 4th point. Let me take the 4th point there. And this is my 5th point. 5th point is lying on the E line. Okay, I have taken the points conveniently so that each of them, like each of the 1, 2, 3, 4, 5 will be lying on the respective A, B, C, D, E, F, so on. Okay, now this is my 1 and this is my 2, this is my 3. Okay, this is my 4, this is my 5, and this is my 1. This is what it is. So all the points from here, like 1, 2, 3, 4, say wherever it's cutting, like I'm just projecting them onto the respective lines, or these are the long edges of the prism, like, right? Now let me just join these points to form a solid. Like now I'm using an HB pencil from here. Okay, let me just join these things first. This is my 1 and 2. This I'm using a straight line here. Okay, since the cut surface is a straight line cut, as you can see in the model which I showed you earlier, and this is the straight line as well. Similarly, this is my last joint 5 to 1. So this is the bottom part which has been developed, and then the top part has been gone, right? As you know, the top part has been removed, so the bottom part is the one which is remaining. So this one is darkened out with an HB pencil. I'm using a pen for an HB pencil, and of course these are also solid lines because you see these edges, right? The edges are there. This is also solid lines. So you could have drawn this with an H pencil. You guys use pencils. So all this construction, initial construction was in H pencil. So H pencil drawn, and then now the development, whatever has been developed. So that is like A2. So there's 1, 2, 3, 4, 5, 1, and then the A1, B1, C1. This part is remaining part. So this is the development of surface. Okay, here like you have to know what is this width. This width is nothing but, if I am just showing you, the width of this one is nothing but whatever the width of this one is. This is 25 here, so this has to be 25. So this is your first problem. Okay, let's move on to the second question. Please you can just note down and then do this problem later. So we'll move on to the second question. So right here in front of us we have a problem. This is a cube problem. Okay, you all are familiar with the cube. You have done several problems in cubes. So just look at this question. Okay, the question says the cube of side 40 mm is resting on HP such that one of its faces is making 30 degree to VP and axis 40 mm in front of VP. Okay, the one of its faces is making 30 and axis 40 mm in front of VP is cut by a section plane perpendicular to VP, inclined at 50 degree to HP, and passing through a point 25 above the base. Develop the bottom part of the cube. Okay, so first things first, let me get started off with the base shape. The base shape is a square. Obviously it has square. Cube has 6 square faces. Okay, you can interchange them for a face and a base depending on how it is resting. Okay, whatever face it is resting on HP, on VP, or wherever that is called a base. Okay, the lateral surface would be called the faces. Okay, as you know, right? Now let us see how this cube is resting. The cube is resting on HP, that is clear. And then one of the face, this is like A1, D1, D. This face is making 30 degree to the VP. This is my 30 degrees. Alright, so from that, in the top view, I'll see my square base. Okay, and then in the front view, I'll have to project these points. Let me just project these out. I'm just drawing them lightly. These are the projection lines. Okay, this is the first thing. I'll just draw the outline and then give the names to it according to the visibility of the solid line. Okay, now this is like this. A is a solid line. This is how I'm seeing solid from. So A is a solid line, B is a solid line, C is a solid line. These three are definitely solid lines. There is no confusion here. And then this is the one we have behind my sight. So this is definitely a dotted line. Okay, this is my dotted line. So I've named these points as A1, B1, C1, D1, so on. Now this is cut by a section plane, perpendicular to VP, inclined at 50 degree to HP. Okay, perpendicular to VP means this is how it's perpendicular to VP. So in the front view, I'll see the trace which is passing through 25. This is like assuming that this is, well, this is given as 40. So this I know this is 40. Right. So 25 from here above, I'll just mark a point here and then set my drafter to a 40. This is 45. So I'll just make it a 50-degree angle. Right, so let me just draw the section here. I'm just using the section, a red line for the section. So then it's like darkened, just so it tells me that it's a section plane. Now tell me how many points is this solid being cut by the section plane, the current section plane, and how many points is it being cut? Okay, like I said, at the bottom it's cutting the base. So between these bases, like there is an A1, B1, right, and then A1, D1 also. Just two lines are there. Two lines are being cut, and here on the lateral surface I have B1 line cut, and then I have my DD1. It's not cut. DD1 is not cut, but between DC and AD I have one more cut here. So however, this is the top part, top base. This is the bottom base. Remember these 2 points. Alright, now let me just get the points where these are lying. Let me just draw this point from here. Like this is cutting the base, right? So this is where this point is cut. This is like one point, another point. And similarly, if I drop this down, I have top base cut. Okay, between these 2 points I have one more point here, one more point. If you want to count it, you can count it as a solid line here. So starting up from here, well, there is one point here also, the B point. So I'm counting up from here. Number one is on this side. Okay, one. Second solid line, third solid line, fourth solid line. Okay, and then this is my fifth solid line. So if I have to number this, the one which I'm seeing in front, up front, 1, this is my 2, this is my 3, this is my 4, and this is my 5. This is how I am numbering. Okay, the ones which up front, right in front of my eye are 1, 2, 3. These are the solid lines. The one behind my sight are 4 and this is like normal 3. Okay, I'm putting dashes here. So 4 and 5 are hidden. 3 is seen normally. Right, so 4 and 5 are behind my sight. So this is how it is. Like if you have to draw the section, you have done the section planes, sectioning of solids. Look, this is like part of section problem also. You guys can do it, but this is now I am talking about only a development problem. So the part which is being cut, like whatever I see, is within this range to this range. Okay, if you have to draw the section, you can still draw the section for this one. This is how the section will be opened out, right? If you want to do the section, this is what the part removed. Okay, this part will remain, this part is gone. So only this from here till here, this is what it's sectioned out. And this is just for your knowledge. Okay, you have already done the sections, so you shouldn't have an issue with this. Now all I have to do is development. Okay, development of this surface. Like I'm drawing parallel line. Still, this is the parallel line method for the prisms, because cube is coming under a prism problem also. So now this is what it is. Now I'll take whatever the side of the cube is. So cube will have 4 sides, and then I'll take 4 sides developed out. These are my 4 sides developed out. I'll just erase this part, it's not required.